Good day, everyone. Today we are going to have chemical reactions and equations as part of our lesson for this session. For the part one, we're going to discuss about word equations and formula equations interpretation. Our learning goals and standards will be identify the reactants and products in a given chemical equation and explain the steps in writing chemical word and formula equations. And we will be able to use appropriate symbols to describe the given equation. As you can see, chemical changes is everywhere and taking place in all aspects of our lives, such as burning of natural gas, generating electricity, car fuel, and even for cooking of food and all chemical reactions. These are actually taking place in any forms of our daily norms. So might as well we want to give the idea about how things might be doing in a simple manner or in a chemistry way. Word equations is a word is in chemistry is a word equation in which a chemical reaction expressed in words rather than in chemical formulas. So we use the names of the elements or the compounds together, and we have to state it with by by um, giving signs. For example, if there is a combination for the two compounds, we will use addition sign and then an arrow sign that indicates the reaction. So our equation should state reactants and products. So remember, reactants should always start at the beginning of the equation or it's always include the starting materials. And for the products, it should be the list that I can say is always it is in the ending materials. It has ending materials. It should be always in the left side and the direction of the reaction in a form that could be used to write a chemical reaction. We have to remember that word equation helps us to reinforce the thought process that involves in chemical reaction or equation. Simply because we can again determine where is the reactant and where is the product side. So normally the reactant side is always in the left side of the equation and the product side is on the right hand side. We have the following example. So when a silver is exposed to sulfur, it reacts to form silver sulfide. So the sulfur that contributes to the tarnish can come from traces of sulfur in the air. So the word equation for the process is silver plus sulfur because we expose the sulfur to the silver sulfide as stated in the given problem. Then we will put an arrow going to the right so indicate there's a reaction. And we will write silver sulfide because again, uh, that is actually the outcome of the exposition of silver metal to the sulfur. Another example is if you're going to burn a chemical reaction, if you're going to burn a fuel like methane that reacts with the oxygen gas, the products of the reaction in the burning of methane as well as other fuels are carbon dioxide and water. So to indicate that in the word equation, we will have the following: methane plus oxygen because we have the reaction between the two, and that will be leading us to the idea that these are our reactants. And then carbon dioxide plus water will be our products. Okay, so you can also browse for these word equations that you are seeing in the screen. You have this also in your Schoology account. You can copy the link or click the hyperlink so that it can be redirected to the site. You can practice. Actually, it has also the answers for each one of that so that you'll be able to familiarize how you're going to make word equations. Now, how are you going to make formula equations? That's the same rule. In chemical equations, for the word equations, you're going to write it in the word form. But in the formula equations, you just need to use symbols of a chemical formulas to indicate the starting material, which is the reactant, and the final compounds are the products, which are written on the right side of the equation. That's the same. You just need to write the chemical formula instead of the word. Okay? So for example, the chemical reaction for the ammonium dichromate volcano is, so you have NH4 2 Cr2O7 to emphasize that this is ammonium dichromate. Then we have to put an arrow, so that will lead us to the next part of the equation, which is the products. We have Cr2O3, chromate, nitrogen, and then 4H2O, which is the water. Okay. Example, another is we have to again um, be mindful of giving the arrow sign or doing the arrow sign. It should be from from left to right. So the arrow is read as yields or reacts to form or produce. Okay, so that is actually how you read the arrow sign. If you're going to decipher what is the equation or formula in word equation, it indicates the ammonium chromate, dichromate. The reactant side yields to the chromium 3 oxide, nitrogen, and water. And the equation for this reaction is even more informative if you're going to see it in the next slide. Okay, so as you can see, again, the NH42 Cr2O78 or the ammonium dichromate is our reactant. Cr2O3 nitrogen and the water is our products. Okay, we have also to remember that in chemical writing formula, especially in formula equations for chemical reactions, aside from the chemical formulas, we have to indicate also their states of matter or the physical states of each compound. So we have to remember that for the solids, we will have S, small letter S. For the liquid, we have the letter L. For the gas, we have G, and for the aqueous solution, we will write AQ. So a solution of the substance in water. So if you have more time on, or if you want to learn more about this part, you can have the following suggested readings by clicking the following links. It could be very helpful in our study about this chemical word and chemical formula writing. Now, writing chemical equations. So how we're going to write chemical equations? So remember, uh, we have lessons last times about the gaining and losing of electrons that yields to ions. So that is actually chemical bonding, or by sharing of the atoms to form molecules. And this actually combination of different chemical formulas. So with this, we need to extend the symbolism to represent the identities of relative quantities, either by that which undergo chemical changes that involves in balancing and chemical equation. So how are you going to write equations, especially in chemical equations? One, the substance undergoing reactions are called reactants, and the other one is called product. Again, the difference between the reactants and product, reactants is actually the one that undergoes reaction, and the product is the final formation of the compound or the generated substance, the new generated substance out of the reaction. So that is the product. So their formulas are placed on the right side for the products. For the left side is always the reactants. We have to put also plus signs. That's actually if if the needs arise. Okay, so if we have plus sign, that indicates we have the reaction to form, and an arrow also indicates uh, that this is a chemical reaction. Second, it separates the reactant and product, and the sides of the equation will be placing to the left again is the reactant, to the right is the products. So number 4 is the relative numbers of reactant and product species are represented by coefficient. So usually there are whole number, and they have to be 1 is typically omitted. For this reason, so all of those chemical equation that does not have any number, coefficient number, is understood. It has 1. Again, in balancing, I'm going to give you an idea. In balancing, we only see in inspection method, we try to convene only on the coefficient. We never ruled out for the subscript. Okay, we have sample problem number 1. In a precipitation reaction, sodium hydroxide solution is mixed with iron 2 chloride solution. Sodium chloride solution and insoluble iron 2 hydroxide are produced. Write a balanced chemical equation including the state symbols. So we have to know first, inspect the problem. So we have here sodium hydroxide solution that is reacted and mixed with iron 2 chloride solution. So definitely this is our reactant. Then we have the sodium chloride solution and insoluble iron 2 hydroxide, which is the product. So write a balanced chemical equation. So we need to identify first their formula writing so that we can have the formula chemical writing equation. And then remember, sodium hydroxide solution is actually the states of the matter of that is solution. So it's AQ with iron 2 chloride solution. It's AQ again. For the sodium chloride solution, it's AQ again, aqueous solution. Then insoluble ion, it comes, the keyword is insoluble. So this is actually solid. So this is actually the part by part how you're going to solve the problem. One, identify the reactant. We have identified the reactant already. The reactant is R, sodium hydroxide plus iron 2 chloride. Then we have to identify the product, which are the sodium chloride, iron, and hydroxide. For the step number 2, we will convert the chemical names into chemical formulas and place them based on the chemical equation and write the state symbols. So we have here, okay, our chemical formula for sodium hydroxide is NOH plus, remember, we have to indicate also the state symbol, which is EQ, and the iron 2 chloride is FeCl2, AQ, yields into, so we will put an arrow, and then NaCl, which is AQ, plus FeOH2, which is also a solid. Okay? So we have to indicate the physical state, okay, of a given substance or a given compound. So if that is the case, that's the complete chemical equation already. Okay, is this a balanced equation? So by means of inspection method, we can say that we can tell if it is a balanced equation. If not, we have to indicate numbers to generate if it is balanced. So later on in our topic, we will see how we balance a chemical equation using inspection method. Okay, for the sample problem number 2, you're going to write a balanced chemical equation for the sodium plus hydrochloric acid yields into sodium chloride plus hydrogen gas. We're going to convert the chemical names into chemical formulas, place them on based on the chemical equation, and write the state symbols. This is actually the same how we did in the last problem. So again, sodium is solid, so Na is S. What makes them solid? Because they are metal. And the hydrochloric acid is a solution, it's AQ. So its chemical formula is HCl. We have to indicate plus sign. So Na plus HCl yields into NaCl, that's the sodium chloride, plus hydrogen, that is the H2. Because hydrogen is the diatomic molecule. Okay. So for this part naman, we're going to have the balancing of the chemical equations. So at the end of the lessons, we will be able to explain the steps that involves in writing a balanced chemical equation and identify different combination reaction and predict the product of a simple combination reaction. So you can watch the video if you wanted so that you can have the balancing of the chemical equation. What is a chemical equation? Remember, it describes a chemical change. So we have to identify again the reactant and product side, and that is being separated by the arrow sign. So again, the reactants is the part of the equation that starts with before the reaction and always written in the left side of the equation. For the product, the new chemical form by the reaction is always placed on the right side. So the subscript and the coefficients are actually two crucial points in determining the balance, if the equation is balanced. So the subscript shows how many atoms of an element are in the molecule. This actually corresponds with the bonding. The charges for the ions constitutes the subscript. For the sharing of the atoms is also the same. So for the polyatomic ions, they have different subscripts that might be intertwined with the parentheses. So that means it has also a number of subscript. But nevertheless, in balancing, we will not be focusing on subscript. No. So the better technique that you can use is you have to focus on the coefficient rather than the subscript. Because subscript is actually the one that constitutes the chemical formula of a given compound. For the coefficient, it has to tell you how many molecules do you have, how many ions do you have. Okay? And it's very important in balancing because we want to know if the number of elements in each side is actually balanced. Okay? So by the coefficient, it shows how many molecules you have in a particular chemical reaction. Okay, for this instance, a chemical reaction 2H2 plus O2 yields it into 2H2O is a chemical reaction occurs when a hydrogen and an oxygen atom combines and forms a water molecule. Is this a balanced equation? Okay, can we tell it? Yes, it is a balanced equation. How can we tell? Simply by means of inspection method. So if we're going to have inspection method, we will have the following. Okay. So let's inspect first the uh, reactant side. So you have two elements which are hydrogen and oxygen. Forgive me for my handwriting because I'm using just a board. Okay. Um, for the hydrogen, how many atoms do you have? Okay, you have actually the coefficient is 2. And you have also the subscript of 2 for the hydrogen only. What you're going to do is you're going to multiply 2 to the subscript. Okay. And that will leads you to the 4 number of atoms. Okay. For the oxygen, you have 2 number of atoms. And for the hydrogen on the other part, which is the reactant, it's the same also. We just omit the plus sign. So we will multiply 2 to the subscript of H, which will give us 4, the same. I will write here in the other side so that you can see. It's actually 4. Okay. And for the oxygen you have here, you don't have any subscript for the oxygen, right? But you have the coefficient because it is part of the given equation already. So it's constituted as a one molecule. So definitely you're going to multiply 2 times 1 because you have only one subscript for the oxygen. So 2 times 1, you will have 2. So that means in the product side, you have 2 number of oxygen, and then the reactant side, you have also 2 number of oxygen. So that means you have balance for the oxygen, and for the hydrogen, you have also the same for the reactants in the product side. Okay. So what can you observe and what can you tell about the chemical reaction, or what is the essence of having balanced equation? It's because um, we have this scientific basis about the law of conservation of mass. So in any chemical reaction, energy cannot be created nor destroyed. The matter is neither created nor destroyed. In other words, the numbers and types of atoms going into in the reaction must have the same number of and types of an atoms coming out in two because it obeys the law of conservation. If it is balanced. So everything that is being created, or I mean everything that is being happening in our world is actually constituted by reactions of chemicals. But nevertheless, their matter, their energy is never created, neither created or destroyed. That's why they must have the same numbers of atoms and its type. So kung chlorine, kailangan pa nagkaroon ng reaction ni chlorine pa rin doon. Hindi siya pwede mawala unless catalyst siya. Okay. Next, how are you going to balance an equation? This is an example of unbalanced equation. So we have here CH4 plus O2 yields into CO2 plus H2O. We have here the reactant side and the product side. So our reactant side here is the CH4O2 or the methane and oxygen. And for the product side, you have the CO2 plus H2O, which is the carbon dioxide plus water. Okay, if you're going to inspect, we have one carbon atom for the reactant side. For the hydrogen, we have four. For the oxygen, we have two. For the product side, we have one carbon atom. And then we have oxygen atom, which is one for the carbon dioxide. I mean, two for the carbon dioxide and one for the water. So summing up all, you have three oxygen atoms. And then you have two hydrogen atoms for this product side. So we don't see any balance at all from these given elements. So there's a need to balance the equation. So to balance the equation, we have the following. Okay, we will write coefficient here in the oxygen. If you're going to observe in the previous slide, we see that in hydrogen, we need to add two more to the product side so that it can catch up with the reactant side. So dalawa pa kulang natin dito, kailangan niyang magkaroon ng dagdag na dalawa pa para parehas sila no sa reactant side. Doon naman sa side naman ni product, kailangan niya pa ng isa para doon sa oxygen atom. Okay? Para magpareho sila doon sa reactant. Okay? So yung reactant, it needs one more oxygen atoms to become three. So in this case, if we're going to have here, it always comes in the point that it becomes divisible. Okay? So if we're going to add two more for the hydrogen here in the product side, we will have 2H2O. So that means you have now 2 times 2, you will have 4 hydrogen atom. And then for this part, you have now 4. So it's balanced for the carbon and for the hydrogen. For the oxygen, since we have only here 2 and we have only here 3, we will add um, the numbers which is actually to the coefficient of the reactant side since the reactant side is the less. But we have also to rethink that we added already the coefficient to the molecule of the water to the H2O. So that's why we will adjust here from 3 to 4. Okay? So bakit siya naging 4? Kasi 2 times to the subscript of 1 is uh, actually 2 plus the oxygen atom in the carbon dioxide, which is also 2. So that's why you have 4. For the oxygen atom in this other side, you have already, you're going to write coefficient 2. Okay. Then you're going to multiply it with the subscript, you will obtain 4. So we have now 4 oxygen atoms and then both for the reactant and product side. Okay, the rule of the game is matter cannot be created nor destroyed. That's why you have to be very careful that it should be balanced both for the types of elements and for the numbers of atoms. Subscript cannot be added, removed, or changed. You have to completely disregard of that. Okay? But sometimes there are problems that you need to fix also their chemical compounds. But that's actually very rare. So you have to disregard the subscript and focus only on the coefficient if you're doing the inspection method. You can only change coefficients. And that's actually a fact. That's actually the technique on how you're going to make chemical balancing. Coefficients can only go in front of chemical formulas. They cannot go side to side. They cannot go in the middle. They should always constitute the chemical formula at the beginning, never in the middle of a formula. And there is also a few extra tips. Try to balance big formula first. That's correct. And save free elements for the last. If the same polyatomic ion appears on both sides of the equation, it's usually okay to treat it as one unit. It's okay. Don't worry about that. Then there is no one particular way to balance equations. You can develop skills, you can develop your own strategies and techniques, but nevertheless, the rule of the game is you can only change the coefficient and make sure that the number of the atoms and the types of elements are always the same for the reactant and the product. So some equations are harder to solve and to balance. The other might some require creativity to solve. Again, you have to be very careful in balancing, especially for the polyatomic ions. Let's have a drill. So for balancing equations, we have the balance to balance the following equation by adjusting coefficient. So we have the following: N2, N2H2, and NH3. So we have here the reactants is actually here. If you're going to inspect first, you have 2 for the nitrogen, and for the hydrogen, you have only 2. And for the product side, you have only 2 for the nitrogen, and for the hydrogen, you have 3. Since we have obtained already a number that's good enough for the nitrogen, we will focus on how we're going to balance for the hydrogen. So since we have, on the product side is we only have 3, and for the reactant side we have 2, we need to raise uh, the equation, or I mean the coefficient to the reactant side. So to obtain the number that we needed, okay, we needed to produce in our um, excuse me, in our given equation, we have to make sure that, I'm so sorry. For the hydrogen, we have 6. I'm so sorry. We have 6 for the hydrogen. I cannot speak for the this is recorded, but I think this is something that I can um, correct about. Yeah, for the hydrogen, ulitin natin, for the nitrogen, you have 2. For the reactant, for the product, you have 2 because the 2 just being misplaced for the position. It should be written here. Forgive me for my handwriting. Yeah. Then, for the hydrogen, you have 6 for the product, and for the reactant, you have only 2. So to make the hydrogen atoms in the reactant side to become the same with the product, which has 6, you need to have a coefficient that when you multiply to the subscript of 2, you can obtain 6. And that is 3. Okay? If you're going to multiply 3 by 2, you get 6. So that means you have now a balanced equation for this particular problem. Next, you have to balance the following equation by adjusting the coefficient. Okay, what is our number of reactants here? For the um, for the reactant side, we have KClO3 or the potassium chlorate yields into KCl plus O2 or the potassium chloride plus oxygen. So for the letter K, we have for the reactant Cl and O. We have 1 for the reactant for the potassium. For the chlorine, we have only also 1. And for the chlorine, we have 3. And for the product side, we have 1 for the chlorine, I mean the potassium rather. And then for the chlorine, we have 1. And for the oxygen, we have 2. So that means we have now balanced numbers of atoms for the potassium and chlorine. We will need to focus to let us to balance the oxygen number from reactant and product. Since we have in our reactants, we have 3, we need to raise somewhere to balance it with the number of reactant side. So how are you going to do that? Okay? So you need to add coefficient numbers. Okay? If you're going to see, it should this number should be placed here. Sorry for the error because of the PowerPoint. Dapat nandito yan. It should be 302. Sulat ko lang. Yan. So 2KClO3, since we obtain or we write on the other side, we write 2, okay? So we will multiply all of the parts of the equation so that if we can obtain number 2KClO3, so we will obtain 2, and then for the potassium, for the chlorine, we will have another 2, and for the oxygen, we will have another 2 times 3, which is 6. And for the other side, we will obtain 3O2. So that is 3 multiplied to 2, that is 6 for the oxygen atom. Okay. So for the potassium, since we obtain 2 atoms for the chlorine and potassium, since we added it to balance the oxygen, we will adjust also the chlorine and the potassium as well to the product side. We will just simply add 2 coefficient number. That means you will have 2 for the chlorine and potassium. And our final equation will be 2KClO3 yields into 2KCl plus 3O2. Okay, balance the following equation. For the next one is C2H6 plus O2 yields into CO2 plus H2O. So how are you going to write this chemical formula? Okay, so inspect first. You have how many in this particular part? We have, for the carbon, we have 2. And for the hydrogen, we have 6. And for the oxygen, we have 2. And forgive me for the numbers. I just using the mouse. And for the carbon dioxide, we have 1. And for the oxygen, we have 2. I'm so sorry. We need to obtain first the hydrogen. The hydrogen is 2. Yeah. And for the oxygen is actually 3. So we need to balance the equation. So we see that we need to balance first the carbon, hydrogen, and then oxygen. So to balance it, we need to have, yeah. So we have to put the following coefficient, 2, 7, 4, 6. How we are going to do that? Okay. So we try to put 2 here in the C2H6. So magiging 2 times 2, magiging 4. Then magiging 2 times 6 is 12. Okay. No. Yeah, 12. Tama pala, 12. Sorry. For the oxygen, it remains 2. So we will put here instead 7 for the coefficient. We will make it 14. How many is this one already? It's 12. I have to write it very careful. Yeah. Okay. For the for the carbon is 4 because we multiplied with 2. For the hydrogen, we have 6. That's multiplied to 2 coefficient. We have 12. And for the oxygen, we have 7 multiplied the coefficient. And the subscript is 2. So we have obtained 14. So for the other side, we will add, since we need the same number for the carbon, we need 4, and we have already 1. We're just going to put the coefficient there. So let's write the coefficient in the carbon, which is 4. Okay, and for the hydrogen is yeah, we're going to put 6. Why? Because we need 12. We have now the 2. So we will multiply 2 by 6 to obtain 12. And the coefficient will be 6. Forgive me for the poor handwriting. I don't have my stylus right now. Yeah. So ibig sabihin, parehas ng balance yung carbon and hydrogen. And for the oxygen, we will have, yeah, that will be 6 multiplied to 1. Ito siya. 6 will multiply to 1. So that means you have 6 already. Then, you may 4 ka dito sa carbon and oxygen atom. So 4 times 2, you will have 4 times 2 is 8. So 8 plus 6 is actually 14. Okay? So I will write here 14. You have now a balanced equation because you have 4 carbon atoms in both sides of the equation, product and reactants. And for the hydrogen, for the reactant and product, it's also the same 12 number of atoms. For the oxygen is you have 14 number of atoms. And the final balance equation will be 274, 272C2H6 plus O2 yields into 4CO2 plus 6H2O. So that is actually the balance equation. Okay, so the tips that you can give is you can always start with getting first the list number. Then you start with the metal. If there's no metal, you can proceed with the non-metal. And then after that, you can proceed with the hydrogen and oxygen. Next, balance the following equation. Fe plus O2 yields into Fe2O3 or iron plus oxygen yields into iron 3 oxide. So let's inspect first what are the elements in the reactant side. The reactant side is Fe. We have 1. And for the oxygen, we have 2. And for the iron in the other side, that is we have 2. And for the oxygen on the other side, we have 3. So that means we need to balance the equation by having the same number of iron and oxygen. So to do that, we need to write 4 to the product side, I mean to the reactant side, making it number 4. And for the other side, we will write 2 so that the 2 number atoms of iron will become 4 already because the number 2 will multiply into the subscript. So that's 4. So I just put it here. Yeah. Okay. And for the oxygen, we will have, we're going to put 3 for the reactant and we shall multiply only the number 2 coefficient, the same with the iron, to the subscript of oxygen to the product side. So to the reactant, we have 3. So 3 times 2 to the subscript, we have 6. And for the product side, 2 times 3 will obtain 6. So that means you have the same number of atoms. So if you want to know how to make more of on terms of balancing, you can have the following suggested readings, and you can browse more on this example, or you can rewatch the video. You can pause a while. If you have questions, you can message me on Schoology. If you have time, also you can watch the video. You can scan the QR code, or you can also visit the link, copy the link as well, and it will redirect you to the YouTube link. So for the reference of this discussion, we have Paul Flowers, which is from the chemistry tree, from the Hastons and OpenStack University, Rice University, given by OpenStack's organization. So that will be all, and have a blessed day.